back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of May 17th, 2018, and our topic tonight is Math 8 Enrichment. And we're looking at exponents again, and again, this is a preview of algebra. This is raising a power to a power. Let's get started. Alright, so we are working again with our exponents, and I want you to see a math fact that you all know. Alright, so taking you all the way back to about third, maybe second, maybe even second grade, 8 squared equals 8 times 8, and 8 times 8 is 64. Alright, that's a fact that we all know and we're all comfortable with. I'm going to write that a different way. So what if I wrote 8 as 2 times 2 times 2? 2 times 2 is 4, 4 times 2 is 8. So there's my first 8, and I'm going to do that again with my second 8. 2 times 2 times 2 times 2 times 2 times 2. That's still 8 times 8, and that's still 8 times 8. It's just a different representation. I have 2 times 2 times 2 times 2 times 2 times 2. That's 6 2's. So that's 2 to the 6th power. All right, 2 to the 6th power is 64. Now, I'm going to write this a different way. I'm going to write this as 2 to the 3rd power squared. Okay, 2 to the 3rd power squared. And what I'm writing here is 2 times 2 times 2. That's 2 to the 3rd power squared. All right. That becomes 8 squared. 2 times 2 is 4. 4 times 2 is 8. 8 squared is still 64. Now, here's a shortcut. 2 to the 3rd power squared can also be written like this. Our base is 2, and that stays the same. So we're just going to rewrite our 2. But our exponents, we multiply. 3 times 2 is 6. So we have 2 to the 6th power. Now, our strategy here is when you raise a power to a power, you multiply your exponents. All right. Now, this will make sense, I promise. And let's move on. Here's the first problem, number 7. 3 squared raised to the 3rd power. Okay. Once you all get the hang of this, it's so simple that you'll be happy I started with the tough questions. And it doesn't get too much worse than this. All right, it doesn't get much worse than that. So let's see, 3 to the 2nd power raised to the 2nd power raised to the 3rd power. So our base is 3, and our math here is just 2 times 2 times 3. All right, so 2 times 2 is our first move, so 2 times 2 is 4. So that inner set of 2's becomes 3 to the 4th power, and we haven't done anything with that 3rd power yet. But now we can multiply it. So 4 times 3 is 12, and that becomes 3 to the 12th power. Now, if you put that in a calculator, you're going to get 531,441. But for our purposes, 3 to the 12th power is just fine. All right, let's try another one. This is number 8. This is 4 squared raised to the 2nd power, and then raised again to the 2nd power. So how do we handle it? The exact same way. So our base is 4, and our exponent math is just 2 times 2 times 2, and that's 8. 2 times 2 is 4, 4 times 2 is 8. So, like I just said, let's do our inside 2's first. So 2 times 2 is 4, that's 4 to the 4th power squared, and then 4 times 2 is 4 to the 8th power. Now, if you put that in a calculator, you end up with 65,536. So that's the answer to number 8. Let's go on to the next one. Here's number 9. 2 to the 3rd power raised to the 2nd power raised to the 3rd power. And here's our base, 2. That's not going to change. But our exponent math is 3 times 2 times 3. And we get 18 from that. So where do we get that? Let's go back and look at this. Base is 2. 3 times 2 is 6. So that's our inner set of exponents. That's knocked out. Now, we work with 6 times 3. So we end up with 2 to the 18th power. Put it in the calculator, you get 262,144 as your answer. All right, so going on. And also I wanted to add right here that sometimes mathematicians will use shortcuts for really large numbers, and in sort of the same way that they use scientific notation, they can also use this kind of exponential notation for really large numbers. All right, and you may see something like that in astronomy where you're talking about tens of billions of miles. You may see it written this way as well. So all right, going on, and this is our next one. Now I'm showing you all the answer for this one. I'm showing you all where we start and where we end. This is 6z to the 4th power raised to the 5th power. If you look at how this progresses, it becomes 6 to the 5th power times z to the 20th power, which becomes 7,776 z to the 20th. Now, how did I do that? All right, let's take a look at it. Now, we're going to start with the 6. This is just 6 to the 5th power. We're not even looking at the z. So we're just looking at our numerical base. So 6 to the 5th power. And remember that when you don't see anything, you understand that to be 1. Any number to the 1st power is itself. So 6 to the 1st power is 6. And our base is 6. And our exponent math is just 1 times 5. So that becomes 6 to the 5th power, or 7,776. Now we can take the z and take a look at it. So here's z. It's z to the 4th raised to the 5th power. This only has one step in it. So this is going to look a lot like my example with the 2's and the 64 and 2 to the 6th power. We're going to take our base z, and we're going to multiply our exponents together. 4 times 5 is 20. So we have z to the 20th. Now we just put them together. It ends up being 7,776 times z to the 20th. All right, this is number 11. So we're looking at 8c to the 8th power raised to the 3rd power. So let's look at our numerical base first, the 8. So our base is 8, and we have that invisible 1 there. So every time you see a number or you see a variable with nothing there, there's a 1 there. Just like we don't write 1 as a coefficient, we don't write 1 when it's an exponent either. So that's that 1 times 3 equals 3. So we have 8 to the 3rd power. Now let's look at c. c has an exponent of 8, so we're going c to the 8th power times 3. So we're raising c to the 8 to the 3rd power. So 8 times 3 is 24. So we have 8 to the 3rd power times c to the 24th power. Now we can simplify this a little bit. 8 to the 3rd power will actually give us a number. So 512c to the 24th power. That's going to be your best answer for this one. Whenever you have a number and you're raising it to a power and an answer, go ahead and simplify it. So that's 512c to the 24th. All right, going on to the next one. Now this is number 12, and with number 12 we have a numerical base and we have 2 variables, both raised to a power. We're handling this step by step in the same way. So let's go for it. Looking at -3, that's our first base we're going to examine, and that -3 has that invisible 1 there. So -3 to the 1st power raised to the 5th power, that's 1 times 5. So we end up with -3 to the 5th power. The next thing we're going to look at is our base a. A has an exponent of 5, and we're raising 5 to the 5th power. So for this exponent, 5 times 5 is 25. So we end up with a to the 25th power. And lastly, let's look at b. b is being raised to the 12th power. And b to the 12th power raised to the 5th power is going to just be 12 times 5, and that's going to give you 60. Now I know sometimes we shy away when we see larger numbers, but this is right. It's just another number. So we have b to the 60th power. So -3 to the 5th power times a to the 25th times b to the 60th. And just as we did with our previous problem, we have -3 to the 5th power. We can go ahead and simplify that. That will give us a number. So we put that in the calculator. Be sure to put -3 to the 5th power you're going to get negative 243, a to the 25th, b to the 60th. And that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.